Hey, ladies and gentlemen, welcome back to Chapter 2, The Chemical Basis of Life. This should be the third video in the series of this chapter, so if you missed any of the other two, the first one was vocabulary, the second one was properties of water. So this third one starts our talk about macromolecules. Make that a bit easier for you. Last video, we talked about the water that we use in our body chemistry. Today, we're going to be talking about the food that we use in our body chemistry, but at the microscopic level, at the molecular level, so even smaller than that. So let's jump into this and start talking about atoms and molecules. The chemical basis of life, macromolecules. This is actually going to be a two-part video. So this is macromolecules part 1. And then after this, stay tuned for macromolecules part 2. We are going to start off smaller than the molecules, right? And what's smaller than a molecule? Atoms. This is very important because we are talking about not just atoms in general, but specifically the carbon atom. All life on this planet, all life that we know of, starts off with the carbon atom. Out of all the atoms, this is the most important one because of the way it is shaped. It is made out of 6 protons, 6 neutrons, and 6 electrons. Yes, that is very weird. 666. I didn't do that on purpose. I didn't choose this atom, but it is easy to remember, I suppose. So 6 protons, 6 neutrons, 6 electrons is going to be very important for making life. So this means we call this an organic compound. Right? Organic, if you don't know what organic means in class, I usually try to make this a discussion point. A lot of people think that organic means natural or like healthy or whatever, like more expensive in the store. No, those are all false things. Organic means one thing: living. That's it. Organic just means you're alive or we're alive. A dead body is still considered organic, but all living things are organic. So I don't care if you buy a regular apple at the store or an organic apple at the store, they're both organic. So an organic compound is a molecule used to create life. And that's what molecules made of carbon atoms are going to be. A molecule with carbon in it, necessary for all life on this earth. So the structure of this carbon atom, it is going to be building up molecules using what we call covalent bonds. Now, in physical science, you probably would have learned about 3 different bonds: covalent bonds, ionic bonds, and hydrogen bonds. Covalent bonds are going to be the strongest ones because they are sharing electrons, and atoms do not like to let go of electrons. So they're going to be holding onto each other very tightly. Most atoms, and you're going to learn this in chemistry class, want 8 electrons in this outer ring around the atom. Right? We call this the octet rule. And carbon only has 4 of them, which means there are 4 empty spaces available, 4 spaces where it can hold on to other atoms' electrons. That means it can build in 4 different directions. Because of this, carbon has a unique ability to make some extremely large molecules, which is what you are made out of. 4 extremely large molecules, specifically, that we're going to be talking about. We call those the macromolecules, but we'll get there. These bonds that they make store energy. Lots of energy, actually. It takes a lot of energy to hold on to these electrons. Like I said, they don't want to let go, and they're going to try really hard to hold on. It takes energy to hold on. So we zoom in right here where this carbon is holding on to this hydrogen, then they're sharing electrons there. That means they're pulling on each other. There's a tug of war going on. There's all this energy building up during this tug of war. So if you can actually pull hard enough and break it apart, all that energy is going to come flying out. And that's the energy we survive off of. If you eat some high energy foods, your digestive system is going to help break that stuff down, bring those molecules to all of your different body parts, where you will do this. You are going to break those molecules apart and get that energy for your body. So it is extremely important that we can do that in 4 different directions, because then we get a whole lot of energy for it. So building up from there, if we make a molecule out of carbon, we are going to call that a monomer, right? One organic molecule, right? It is mono. The prefix, it means one, right? I know some of you guys are thinking right now, no, uni means one. You're right. That's a different language, right? Mono and uni both mean the same thing. So one molecule, one organic molecule, they can bond with other monomers because that's what happens in chemistry. You take two different chemicals, put them together, you get a bigger chemical. You take two monomers and you put them together, you get a bigger molecule called a polymer. Poly in front of a word means multiple, many. So two monomers, you get a polymer. Nice and easy. We're going to have three main types of monomers that we care about in this chapter and really throughout this entire school year. We care about monosaccharides, amino acids, and nucleotides. Monosaccharides are sugars. We use those for energy. Amino acids are used to build up your body parts, and nucleotides are for your genetic code. Those are the three very important things. So let's go on bigger from there. Polymer, I already mentioned, is a compound made of monomers. Remember, mono, one molecule, poly, polymer, many molecules. I get a whole bunch of these and chemically put them together to make a bigger one. So this little red dot represents one monomer. And if I can get two of them together connected chemically, now it is officially a polymer. If I add a third one, still a polymer. Fourth one, still a polymer. Doesn't matter how big I make it, it's always going to be a polymer. We don't have a word for bigger than a polymer. We do have another word coming up, but that word is still going to be just a polymer. But we'll get there. How do we make these polymers? Well, the way we're focusing on today is a method called dehydration synthesis. This is our body's way of making a polymer, of taking these monomers and putting them together. Let's break this word down. Right? Dehydration means what? It means you're thirsty, right? It means you have lost water, right? So these molecules, when they're made, they're going to lose H2O. And synthesis, to synthesize, means to make something. So we're going to take these monomers, put them together to make a polymer, synthesis, to make, and in the process, they are going to lose water. That's it. That's your big hint. That's how you know that it's dehydration synthesis. Two monomers bond together, and the new polymer loses water in the process. Take a look at this picture here. This is two monomers. These are all different atoms. I didn't bother labeling them because they don't matter. But what we do care about here and here, if I were to take this monomer and attach it to this monomer, that means this H, and this O would all come together. Two H's and an O, H2O. This would become water. So you put these together, there would be water in it, right? But no, when they get together, they fuse, they synthesize, there's that word again, the H2O falls out. So this now, monomer, monomer, boom, polymer, has lost water. This is the confusing part, guys. I know you guys are going to look at this and think, oh, there's water. It must be gaining water. No, it lost. It's here because it's not in here. This molecule lost water. It was became dehydrated as it was synthesized. And we can make molecules, we can also break them. Hydrolysis is how we're going to break them, right? Both processes are very important. We want to make them, we want to make polymers because that's how you build up your body, but we want to break them because remember, there's energy in those bonds. If we break them, we can get energy and use that energy to make even more molecules to build our body up. It's a give and take situation. So we gotta know how to break these things apart too. And it's easy. We are going to do the exact reverse. Right? So we are going to break a polymer by adding water. Hydrolysis, Lysis is the process of adding water, hydrolysis. And that's easy to show. Let me just go backwards here, and I'm going to run this in reverse. I'm going to take this polymer, and I'm going to stuff the water in there, and that broke it back into its monomers. So when this polymer gets broken, energy comes back out, and now we have the energy to live. So dehydration, synthesis, making, and they lose water in the process. Hydrolysis, you are breaking by adding water in the process. Okay. Dehydration, synthesis makes, hydrolysis breaks. Remember that. All right, moving on to our next word up, macromolecule. If you remember what I said just a minute or two ago, I said we're not going to have a word beyond polymer, and we don't, right? A macromolecule is not beyond polymer, is not bigger than a polymer. It is still just a polymer, right? It's just a really big polymer, right? There are certain polymers that are so important, certain molecules that are so big and vital to your survival that we gave it their own name just out of sheer importance. We call them the macromolecules, a polymer with a very high mass, right? Macro is the opposite of micro. Macro means big, so big molecule. And we have four main types of macromolecules: carbohydrates, proteins, nucleic acids, and lipids. These four are going to make up everything that we are talking about one way or the other for the rest of this school year. Right? These four will be involved in every at least one of these will be involved in every single chapter. So do not forget these. We will always revisit them. So what do they do? What are they for? Why are they important? Well, carbohydrates. You probably heard of going on a low carb diet, right? These are foods that are going to provide energy, right? They're very important. You need them to survive. You cannot live without carbohydrates. So why do we go on a low carb diet? Because if you have too much energy, you don't use it, you store it and get fat. So lower that and you can start dipping into your fat reserves. More on that in a little bit. Proteins, their jobs are to build your body parts. So people who lift weights, you may have heard them having high protein diets, drinking those protein shakes, trying to get more and more proteins into their body so they can turn it into muscle. Right? Protein is what your physical body is made out of. Carbohydrates provide energy so that you can build up your body, but proteins are the actual body parts. And then nucleic acids, that's your genetic information, your genes, right? You've heard that term before, genes, your DNA, your RNA, your genetic code. So your body knows what it's supposed to look like. Right? We're not going to talk too much about nucleic acids. We're not going to talk too much about DNA in this chapter. This is so important. I have it set aside for a whole nother chapter later on. So we will come back to that. And lipids, extra storage. I said we're coming back to this, because if you eat too many carbs and your body doesn't need this much energy, it's going to take the excess stuff and put it in storage, your lipids. And that's what fat is, a whole bunch of lipids. So if you eat too much of something, you're going to try to hold on to it for later. That's what getting fat is. Same thing with too many proteins as well. So, but mostly it's carbs. That's what affects us the most. So if you are trying to lose weight, you don't cut the fat, you cut the carbs, the breads, the pastas, things like that, all right? So before we end this, let's put this into some organization. Macromolecules, these four macromolecules, remember, they are polymers, which means they are made up of monomers. And if you have a handout that I'm going to give in class, you probably have a third column. All right. I'm filming this video before I made a digital version of that paper, so I don't know what yours looks like right now. but the one I hand out in class has a third column. I think it's titled examples, right? That means I'm asking you to come up with examples of carbohydrates, examples of proteins, examples of nucleic acids, which I gave you, hint, hint, and examples of lipids, which I also gave you. So that's up to you guys. But right here, we'll do this together. Carbohydrates, they are polymers, which means they're made up of monomers. Which monomer of the three that I gave you earlier in this video? Monosaccharides. Hey, carbohydrates are your sugars. So mono, remember it's a monomer, mono means one. So one saccharide. Saccharide, I forget if it's Greek or Latin, but it refers to sugar. This translates from either Greek or Latin to English as one sugar. So if you get two monosaccharides together, that'll be a disaccharide, two sugars. And then three is a polysaccharide, which, a disaccharide, polysaccharide, those are polymers, carbohydrates. So we get a bunch of these together, you get a carbohydrate. Next one, amino acids are used to make up proteins. And again, we're going to have a whole chapter on how that works, how we're going to take a whole bunch of amino acids and chemically fuse them together to make proteins. For now, I just need you to know that they do. We'll worry about how later. And nucleic acids, made up of nucleotides. Because if nucleic acids is genetic information, meaning it's a code, it's a message, it's telling you something, this is a language, then nucleotides are the letters of that language. You put these together in the correct order to make a code. And more on that future chapter. And the last one, lipids. What are lipids made out of? Well, this is one of the very few times in existence that I'm giving you a trick question. There is no common monomer. Lipids are kind of crazy, right? There isn't any one kind of monomer. There's a whole bunch of different kinds of monomers that we just are not going to get into. So there is no common monomer for making your fat. So those are the three that you're going to have memorized. All right, so ladies and gentlemen, this is the end of part 1 of macromolecules. Just talking about how you go from atom to very large molecule. Next video, we are going to go into more detail about the specific macromolecules. Talking about carbohydrates, proteins, maybe touch up on nucleic acids, and talk about a little bit about lipids. All right, until then, I will see you in the next video.